FIZZ Pop Rocket. In your kit, you're going to find a tube of effervescent tablets. You're going to need to take those tablets out and put them into the Ziploc bag. This bag originally had the paper clips, the balloons, the bugs, etc. We have to make sure that these stay airtight because these tablets will absorb water that's in the atmosphere. You are going to stick the bug on the lid after you have removed all of the silica beads that are in there. So you remove the paper and tip out the beads, and then that's ready to go. Now in this demonstration, I've got two different types of lids. They both fit on securely, but one of them will fit much more tightly than the other. We're going to do a compare and contrast. You're going to need to get a beaker, plastic beaker or glass beaker with some water, and then also have about 20 milliliters of water in another cup. We really want to have this about third filled, quarter filled with water. The young volunteer is going to require 2 tablets for the experiment and 1 tablet which is going to go into the beaker. And this will allow everybody in the class to see that a chemical reaction does take place and lots of bubbles are given off. You might want to put this in a water bottle and put a balloon over the top and trap these bubbles of carbon dioxide gas inside that balloon just to find out how much gas is actually made by 1 tablet. The water is going to go into the tube and the 2 tablets will go into the tube, and only the apprentice wizard is going to be able to hear it fizzing. At this stage, they are going to need to have to put on their safety glasses. They can be ordinary safety glasses, or they could be funky sunglasses, swimming goggles, anything that's going to protect their eyes from splashes or from the rocket maybe accidentally hitting their eyes. When we put this lid on, the gas inside here is being formed, but it's not able to escape as it is here. So inside, many thousands of these molecules are pushing down, pushing to the sides and pushing up. And once that upward force is greater than that frictional force that keeps the lid on, this little lid is going to fly. I want you to practice this before we do this in the virtual experience so that you know, whoa, whether it's going to hit the ceiling or not. So that one there didn't hit the ceiling. This one here has got a much tighter fit, which means that the amount of gas that builds up is going to be much more. The upward push on this rocket is going to be enormous. So I know it will hit the ceiling. And if it hits the ceiling, it could rebound and hit somebody in the classroom. So if that's the case, you're going to get your apprentice wizard to hold it at an angle parallel to where everybody is sitting. We're not going to aim it at anybody. It could be aimed at a target to their left. The more time that it takes for it to build up the pressure, so that went about 2 meters there. The more time it takes to build up the pressure, then the further the rocket is going to go. You can repeat this several times, maybe 3 or 4 times, but as soon as the chemical reaction has been completed, then nothing will happen. If you get to a point and you're not sure whether there's gas inside, then again, they're going to have their safety glasses on. They're going to hold it away from their face, and using thumbs, we're just going to push it off and release that pressure. So we're always safe. Are we going to get it to fly again? So this is the FIZZ Pop Rocket.